Okay. What are the four ways to solve quadratic equations? One is by factoring. Another method is by completing the square. Another method is by using the quadratic formula. And the last step is to graph the function or the equation that was given to you, and then specifically look for the x-intercepts of your parabola. Some of you said split the middle term. Splitting the middle term is a form of factoring, and factoring is more general. You don't always have to split the middle term to factor something. And some of you said vertex form, which was crazy. Vertex form is to find the vertex of a quadratic equation, not to solve for x. Okay, solve for x by completing the square. Okay, let's do this. First thing you're going to do is divide both sides by a. So we have x squared plus b over ax plus c over a is equal to 0. When you are completing the square, the first thing that you do is you move the constant to the other side. So we have x squared plus b over ax plus something is equal to negative c over a plus that same something. Okay, the number that, or the value that goes there is the middle term divided by 2 and then squared. So b over a divided by 2 is b over 2a, and if we square that, we would get b squared over 4a squared. So b squared over 4a squared. Okay, so this is now a perfect square trinomial, and the factored form of it, it's always x plus half of that. So b over 2a squared is equal to, notice that I'm adding fractions, right? And my fractions at the current moment do not have the same denominator, so I need to make that happen. To do that, I'm going to multiply the top and the bottom by the numerator and the denominator by 4a, because if I do that, then I'm going to have both denominators that have a value of 4a squared. So 4a times negative c is negative 4ac plus b squared over 4a squared. I can write them now under a single fraction because they would both have the same denominator, so that's why I'm allowed to do that. Negative 4ac plus b squared over 4a squared. Okay, now that I have factored my perfect square trinomial, I'm going to try and solve for x by taking the square root on both sides. And so I have this x plus b over 2a is equal to, well, I can't take the square root of the numerator because a and c are not perfect squares. So I couldn't even have like a difference of perfect squares. And then I'm going to change the order of these two terms so that it looks like the quadratic formula that we're used to seeing. B squared minus 4ac. Why are we allowed to do this? Well, isn't 4 plus 5, sorry, hold on. Isn't negative 5 plus 4 the same thing as 4 minus 5? The answer is yes, they are the same. That's why we're allowed to switch the order of the terms. But if I take the square root of the denominator, I get 2a. And then, oh my gosh, look at that. They have the same denominator, which means that I will be able to write this as a single fraction. The only thing that I need to do now is just move this term to the other side. So x is equal to negative b plus or minus, because we're dealing with a radical, of b squared minus 4ac over 2a. I solve for x, and my result is a quadratic formula. Okay, the ages of siblings can be expressed as the ages of 3 siblings can be expressed as consecutive integers. Consecutive integers means that I will have x, then x plus 1, and then x plus 2. The square of the age of the youngest sibling is x, so the square of the youngest sibling will be x squared. Is 4 more than 25 times the age of the oldest sibling? Okay, this word is means equal sign. The word 4 more means 4 plus. 25 times the age of the oldest sibling, that's 25 times parentheses x plus 2. And now we're just solving for x. So x squared is equal to 4 plus 25x plus 50. Or x squared is equal to 25x plus 54. If I rewrite everything in standard form, I will get x squared minus 25x minus 54 equals 0. And I'm going to see if I can factor this. What two numbers multiplied together give me negative 54, but added together give me 25? Oh, this is first period. Okay, so it'll be negative 27 and positive 2. So x has to be 27 or x has to be negative 2. Negative 2 is an extraneous solution because you cannot have negative ages. So the little brother is 27, which means that the middle sibling is 28. And the oldest sibling would be 29. Okay, if you solve this problem by creating an equation, did you get an extraneous solution? Yes, it was x equals negative 2. Okay, solve them. Okay, first thing you want to do every time that you're solving a quadratic equation is you want to rewrite it in standard form. So minus 15x minus 34 equals 0. Okay, I'm actually not going to complete the square on this because look, the middle term is an odd number. And if I complete the square on it, then I'm going to end up with fractions, right? Because you have to complete the square, you have to take the middle term, split it in 2, and then square it. I really don't want to do 15 over 2 and then square that to get 225 over 4. Before I complete the square as my last resource, I'm going to see if this is factorable. Factoring is quicker. Okay, 17 and 2 might work. Let's see. 17 would be negative and 2 would be positive. Bam, that works. So x is equal to 17 and x is equal to negative 2. You must have both answers. And do you see how this is like much easier than having completed the square? Okay, now b squared minus 4b plus 21 is equal to 0. Okay, let's see, can we factor this? Two numbers that multiply together give you 21, but added together give you 4. I know 7 and 3 is 21. Did that work? Negative 7 times positive 3 is negative 21, so that didn't work. If they're both positive, then they would add up to 11, so that doesn't work. And if they're both negative, they would add up to negative 10, so that didn't work. Okay, so now that factoring didn't work, that's when I would actually try and complete the square. And we're actually in luck because that middle term is even, so I will not end up with any fractions. So let's see, if I'm completing the square, I will do b squared minus 4b is equal to negative 21. And hopefully you understand by now that by completing the square, I'm creating a perfect square trinomial on the left side, and then I'm factoring it. So minus 2 goes here, and then negative 21 plus 4 would go here. So b minus 2 squared is equal to negative 17. You take the square root on both sides, and you end up with b minus 2 is equal to plus or minus I square root of 17. And I cannot simplify the square root of 17 any further, so I will leave it as that. The last step is just to add the 2 to the other side of the equal sign. And that's the final answer. Okay, number 7. 4r squared minus 8r plus 3 is equal to 0. Again, we could complete the square on this, and you will get the right answer if you complete the square. But look, if we complete the square, we're going to end up with a fraction here. We're going to end up with 3 over 4. And so before I start completing the square on something where I'm going to end up with fractions, I'm going to see if I can factor it. So and I know that 4 is not going to divide 3, so this is going to be an instance where I have to factor it by splitting the middle term. So I'm going to do 4 times 3 is 12, and 6 times negative 6 times negative 2 is 12, but also added together gives us negative 8. So I'm going to factor it by splitting the middle term. It doesn't matter whether you write negative 6r or negative 2r first. It will work either way. Okay, the GCF of that is 2r, so I end up with 2r minus 3. And the GCF of the next 2 is just negative 1, so I still end up with negative 2r minus 3. Perfect, it was factorable. So I end up with 2r minus 1 times 2r minus 3 is equal to 0. Or r is equal to 1/2, or r is equal to 3/2. And this was way easier than having to complete the square, in my opinion. But you can solve it either way. Okay, this one was from first semester. This was very scary to me when I was grading your assessments, because it made me realize that we're still having trouble identifying the operations that are happening in problems. Okay, in this equation, one of the things that we're doing to x is that we are adding by 4. And so the opposite of adding by 4 would be to subtract by 4. So we end up with 3 times 6 minus x is equal to negative 12. Okay, what else do I notice? I notice that I'm multiplying this radical by 3. So the opposite of multiplying by 3 would be to divide by 3. So I end up with 6 minus x is equal to negative 4. Great. I now have to square both sides to get rid of the radical. So I have 6 minus x is equal to 16. If I'm adding 6, the opposite of adding positive 6 would be to subtract 6. So I have negative x is equal to 10. And then lastly, if I'm multiplying negative 1 times x, the opposite of that would be to divide both sides by negative 1. So x is equal to negative 10. You're not done. Remember, one of the things we talked about during the radicals unit is that you need to, every time that you have a solution, you need to substitute it back into the original equation to make sure that the solution that you got is not an extraneous solution. So I'm doing just that. So 3 the square root of 16 is 4, and 3 times 4 is 12, and 12 plus 4 is 16. 16 is not equal to negative 8. So this is an extraneous solution. Therefore, the right answer was no solution. Okay, this one, rationalize the denominator. You have to multiply by the conjugate. Hope you remember that from semester 1. Okay, I'm going to strategically not use FOIL yet. I'm going to leave it like this. X minus 9, parentheses, square root of x minus 3. Okay, remember these are a difference of squares. So one crazy way to do this is to use the box. So you can do x, the square root of x and 3, and the square root of x minus 3. And you can substitute all of your values here into your box. However, I know that these are a difference of squares, so this is just going to be the square root of x squared minus 3 squared, which is x minus 9 times the square root of x minus 3 over x minus 9. Oh my gosh, what do you notice? These cancel out. So this is just the final answer. And then why is it called rationalizing the denominator? It's called rationalizing the denominator because on the original problem, you had a radical. You had the square root of x, which is an irrational number. And during the process of multiplying by the conjugate of the denominator, you end up with no radicals in the denominator. So you are making the denominator be a rational number. I'm not writing that explanation, but you should on your test, on your retake.